Swayam Prabha. Digital India. Educated India.
Hello friends, welcome to this live session on our course Principles of Mechanical Measurement. Today I am available live here to discuss about your queries and also to see whatever questions you have, if any. Now to share the slides. There are a few queries which are pending for some time on the portal. So I'd like to discuss about that till the time we receive any other comment. This was one of the comments which was pending for quite some time. I thought about responding it, but again giving the answer in writing is a bit difficult. So I thought about explaining that in live session. So the question is related to the level of measurement. Now in the very first module we have discussed that there are 4 different levels of measurement. So I'm just going to iterate on the same thing here. The type 1 is the nominal, or classificatory measurement, which sometimes some theorists don't consider it as a type of measurement at all. So nominal measurement is just dividing the samples into different groups without talking about any particular quality or something. Like suppose a football match is going on, there are 22 players on the field, so we classify them just in 2 groups, group A and group B, without talking anything about their nationality, say their body weight, their height or anything. We just talk about 2 teams are playing, there is a team A and there is a team B. This kind of classification is nominal measurement. And the same way, suppose each of us belong to certain kind of state. So I am a resident of this particular state, you are a resident of this that particular state. This kind of classification is nominal measurement. That's why sometimes we just can some persons just talk it about a classification without any measurement. The number two refers to ordinal, which is definitely a type of measurement. Ordinal refers to relative scale, a completely relative scale where we are talking about the relative position of a particular sample with respect to the entire group. Like suppose there are 10 students are there in a particular class, and they have all appeared in a particular exam. Then instead of talking about exactly what marks someone has got, we talk about, say, this particular student is the second in this particular exam. Now that second is a relative measurement, and that's what we talk under this ordinal category. Second doesn't give any idea about exactly what marks he or she has received. Suppose it was an exam out of 100, and the student may have, if you are telling that he is second, then he may have got 80 marks, he may have got 50 marks, he may have got 20 marks. That doesn't matter, it's just a rank. So ordinal measurement is just that rank. Like we talk about the rank in national level exams like JEE, etc. There we always talk about ranks instead of exact marks. So that's what is ordinal measurement. The perfect example of using the ordinal scale of measurement is the percentile. In a percentile, we talk about the position of someone with respect to the others. That is, it talks about the percentile of a particular student says that how many number of students are below him or her divided by total number of participants. That's why you can never have 100 percentile. Like suppose there are 100 students who have participated in an exam, someone who has got the highest mark, even he or she can't have 100 percentile, because the calculation will be there are 99 below him or her, so it is 99 by 100, that is 99 percentile. So that's what is ordinal scale, which is completely a relative scale. Then we have the number 3, which is the interval scale. In interval scale, we talk about, or rather we decide upon 2 limits and based upon the distance between these two limits or these two standard values, we measure some value or give some value to everyone. A most common example, I think I have used the same during my lecture also. The best example we can give in terms of the temperature measurement. While setting up or while devising any scale for temperature, we decide upon two standard point. One point can be the ice point, that is the freezing point of water. Other reference point is the steam point, that is the normal boiling point of water. Now, when we devise a Celsius scale, we decided that the ice point should be given a mark of 0 and the steam point should be given a mark of 100. And then the distance between these two should be divided into 100 equal divisions, and therefore the length of each division should be 1 degree Celsius. However, the same 2 points, if we are talking about say in Kelvin scale, then it is 273.15 the ice point and 373.15 that is the steam point. Or if you are talking about the Fahrenheit scale, that is 32 and 212. There are 180 equal divisions between them. So the interval division just talks about the distance between these two limits and divide this into equal number of points. And we don't have any definition of any absolute reference point. This everything is relative. Like suppose most of our measurement definitions are based upon this interval thing only. Say think about, we know that the length of one day is 24 hours, but who has decided that 24 hours? It is we have decided that it will be 24 hours. Each hour will comprise of 60 minutes, each minute will comprise of 60 seconds, and based upon that we do everything else. So that interval, suppose if we are trying to measure the time, say this session has started at 3 a.m. or 3 p.m. rather, and we want to continue this for 30 minutes, then we have divided that 3 to 4, this difference will be divided into 60 equal intervals, and length of each interval is 1 minute. So accordingly 30 such intervals will be the span of this particular session. That's what comes under interval. And the fourth one is the ratio, where we have an absolute zero. We need the definition of absolute zero, and there instead of talking about the length of any interval or any relative position like in ordinal scale, we talk about the magnitude with respect to certain reference, certain standard. Say for example, how much is 1 meter? 1 meter is one standard length decided by the International Association. Now, if we say that the length of something is 5 meter, that means it is actually 5 times of that standard reference. And whatever is the length or unit that we are using for that reference, accordingly we have to put some number for the sample that we are dealing with. If our reference, so it is 5 times of some reference. If that reference is 1 meter, then that length will be 5 meter. If the reference is 1 feet, that length will be 5 feet. This way it will go. So regardless of whatever system of unit you will be using, your ratio will remain the same. Ratio of the sample, magnitude of the sample divided by magnitude of the standard or reference, that should remain the same for all measurement of unit. That's what we call about ratio. This is the one that probably most commonly used. Like some weight of something is 5 kg. Now we measure that is 5 kg because that is 5 times to some sample whose measurement is 1 kg, and accordingly we get this ratio measurement. So these are the 4 types of measurement. I hope this is clear. If you have any further query about this level of measurement, you can ask me in the portal. Now this is the second question about how to calculate the uncertainty percentage. The uncertainty percentage refers to, there are actually a couple of ways of defining a percentage. Suppose if I say I am talking about a resistance having a value of 100 ohm plus minus some uncertainty. Now that uncertainty can be given in 2 ways. One is where the absolute magnitude is given. If the absolute magnitude, suppose it is given as 0.3 ohm, that measures, or rather that refers whatever reading you take using, suppose this is the range of one particular ohm meter, it can measure up to 100 ohm. Then it shows that whatever measurement you take with this, there will be an error of plus minus 0.3 ohm. So if you measure, suppose when you are measuring something like 3 ohm with this, you are still going to have 3 plus minus 0.3 ohm, whereas if you are measuring 70 ohm, you are still going to have 70 plus minus 0.3 ohm. This is absolute uncertainty. However, the percentage, again there are, just what I mentioned, there are two ways of mentioning the percent. One is if it is given as 100 ohm plus minus 3% of full scale. Sorry, this 3% of full scale is nothing but the absolute only. That refers that again whatever measurement that you are going to take, that will have plus minus 3% error of the full scale. Now full scale is 100 ohm into 3% of that is 3 ohm. So whatever you measure, there will be 3 ohm, there is a possibility of having 3 ohm amount of error. So if we go back to the previous two examples, when you are measuring 3 ohm, there is still possibility of having plus minus 3 ohm of error. Similarly, when you are measuring 70 ohm, there is possibility of again plus minus 3 ohm of error. This is one way of having uncertainty percentage. The other one, which is most commonly we have, that is 100 ohm plus minus is this okay 3% of reading. If nothing is mentioned, just 3% is mentioned, we take that 3% of reading. That refers to the error, magnitude of error will depend on the value that you are measuring. Like when we are trying to measure 3 ohm, the maximum possible error will be 0.03, that 3% of that 3, that is it will be 0.09 ohm. Whereas when you are measuring 70 ohm, the maximum possible error will be again 3% of that 70, that is 0.21 ohm. So the amount of error that is taking place or that can get introduced, that will depend upon the exact reading, and if only percentage is mentioned, that is the one that we always consider. So this is how we measure the uncertainty, or we make use of this percentage uncertainty. And if you want to know how we calculate this, then we measure the uncertainty and then generally we divide that by the full scale reading to get an idea about the uncertainty value. So the third question that I have, explain the solution for problem of venturi meter. I think you are referring to the third lecture. In the third lecture, towards the end, I left this one for you to solve. But in the fourth lecture, I have given the solution partially. Just hold on, let me find the problem statement once. So I can briefly show you a way to solve it. So in the problem it was given that the mass flow rate using a venturimeter can be calculated as m dot equal to cd into the area into 2 times of the inlet pressure divided by gas constant into inlet temperature into delta P whole to the power 0.5. So if there are several parameters, R is a constant but everything else, all the other 5 are variable, so you need to calculate the dependencies, that is del m dot del cd, then del m dot area, that is dependence of mass flow rate on area, dependency, oh sorry, del m dot to del p in, del m dot into del t in, and del m dot into del delta p. Each of them you have to estimate. Then each of them needs to be multiplied by the uncertainty in that particular measurement, like W into CD, uncertainty in the measurement of CD, uncertainty in the measurement of area, uncertainty present in the measurement of P in, uncertainty present in the measurement of T in, and uncertainty present in the measurement of delta P. So all the values are given here. Then you need to take whole square of each of them. Then add all of them up with each other. And once you have this, then take the square root of everything to get the estimate about the final uncertainty, or actually the absolute value of the uncertainty for this particular problem. One important point to note about this particular problem is that here the values are given in different units. Like P in is given as 2 bar plus minus 0.02 bar, whereas area is given as 6.75 centimeter square plus minus 0.1 centimeter square. It is important that you convert each of them to corresponding SI units and then only start solving. Otherwise, you will be having a mismatch of the units and you may end up with some erroneous result, or you should end up with erroneous result. Similarly, temperature is given in Celsius, 20 degree Celsius plus minus 1 degree Celsius, and this T in this particular relation is absolute temperature. So you must convert it to absolute temperature, that is, it will be 293 Kelvin plus minus 1 Kelvin, and then you can find the uncertainty of this particular measurement. The fourth one, I am not sure exactly what is being asked because the assignments are already there. If you have any more specific query, you can please write to me. And the fifth one, here we are trying to get the mass of an object and getting the deflection in terms of force and in terms of mass also. Then what type of instrument is it? Okay, this is referring to the spring balance. I think you got slightly confused with the picture that I have shown you. In that picture, the spring balance has two scales. One was in Newton, other was given in kg. Actually, instead of kg, that should be kgf, that is kg force. You are never getting a measurement in terms of mass, we are always getting measurement in terms of force, because spring balance gives a measurement of force. It never measures the mass. From the force itself, we get a measurement of mass. Spring balance just measures the weight, and we can divide that by gravitational acceleration to get the absolute mass. But it is quite common that instead of talking in terms of Newton, quite often we represent weight in terms of mass. Suppose if some mass of certain object is 2 kg, we often say that the weight of this is 2 kg force, which actually refers to 2 into 9.81 Newton, which is the true weight for this. So both refers to same thing. Whatever value we will be having here, that needs to be multiplied with 9.81 to get the value in terms of Newton. So we are not getting a measurement of mass, we are only getting a measurement of force using spring balance. So these are the questions which are pending, or which were pending in the portal. If any of you have any other query, I am here and I am ready to respond to you. Hmm. This course we have already completed 6 modules. I think the module number 7 is going on. So you can ask any other question if you have, and whatever queries were pending in the portal, I have responded here. And of course, initially we are slightly lagging with the responses, but as I've told, the first response, etc., also one or two more, they are difficult to explain in terms of writing. It is easier to explain those things, at least for me it's easier to explain um, verbally, and that's why I decided to talk about them during this live session. If you have any query, please write now, because we have some time limitations, and again I have to keep on waiting for your queries here. Principles of mechanical measurement is a very important course for any kind of mechanical engineering, and also students of relevant branches, because here we are talking about the principles of different kind of measurements, or measurements of different kinds of engineering variables, and that is not only limited to pressure or temperature. Rather, we are talking about measurement of forces, measurement of deflection, acceleration, flow, and all these are applicable to any branches of engineering. Particularly the measurement of force, measurement of deflection, measurement of temperature, they are found everywhere, and we are trying to cover as much as we can. Instead of burdening you with too much detailed description, I'm trying to focus more on the principles of different kind of measurements. And as you're into the week 7, in the subsequent weeks, you will be introduced to the measurement of topics like pressure, flow, temperature, etc., which definitely will be very very interesting. I hope the earlier lectures were also interesting, but maybe they will become even more interesting in the subsequent weeks. And in the last module, I have talked about, or I shall be talking about some not so common kind of measurement, like the detection of radiation, detecting the biological effects of radiation, etc. So that can also be an interesting topic to discuss about. Please post your queries here if you have any question at the moment. Of course, there are several other kind of parameters which are possible to be measured, or in certain engineering application we encountered them, like the hygroscopic measurement, the measurement of relative humidity, etc. Those topics are slightly too specific, and so we are not able to cover them. But once you have the idea about the principles of measurements like pressure and temperature, etc., and of course deflection, then you can easily comprehend the ideas of those measurements as well. Particularly the deflection measurement is very important, because most of the other measurements, or many of the other variables, are measured actually in terms of deflection. Like just think about a mercury thermometer. In a thermometer, using a thermometer, we are measuring temperature, but actually what we are measuring, we are just measuring the deflection of the mercury column inside that capillary tube. So, though we are measuring a deflection or change in the height of the mercury column, we are calibrating that in terms of temperature, and accordingly we are doing the measurement. The same way, deflection and force are the two most common kind of variables that are used to measure most of the other variables. And so once you have clear idea about the deflection measurement and force measurement, and in fact force measurement also in devices like load cell, etc., we are either measuring some electrical quantities, or we are measuring again a deflection. So with the once you know the idea of the force and deflection measurement, most of the other devices are not uncommon to you. So maybe we can wait for a couple of minutes more to see if there are any other queries. Some of you are online here, so even if you are not having any query, you can just write in the chat box about your experience in this about this course so far, if you want to share anything. So far everyone is silent, and Let me just see if I am in luck with any question from your side. Otherwise, we may have to wind up this session because it seems no questions are coming from your side. In that case, maybe we can close down this live session. And if you have any query, please write in the portal. I shall be happy to respond to you. And we shall be having another live session later on. We can have interaction that time as well. So, okay, keep sending your queries and be safe. We shall be meeting again. Thank you very much.